Right, we're going to look at conservation of energy calculations, and the first situation we're going to look at is where we have gravitational potential energy and it's changing to kinetic energy. So we're going to take a cat, come on cat, put it up in a tree. Now when it's up in the tree, it has gravitational potential energy, and we'll say that the mass of the cat is 3 kilograms, gravity is 10 newtons per kilogram, and we'll say that the height of the tree, we'll say it's 4 meters, is the height of the cat above the ground. Okay. So its total potential energy is mg delta h, the height. Putting the numbers in, 3 times 10 times 4, it's 120 joules. Now that number becomes important because that's the total amount of energy, put it in red because it's important, that's the total amount of energy in this situation, and that will not change. Now we'll have our cat falling out of the tree, and just before it hits the ground it's travelling at some speed v, and we want to work out that speed. We know when it gets to the ground it's all EK and no EP, just before it hits the ground. We know that the EK value, kinetic energy, must be 120 joules because that's all we had to start with, and all that potential's changed. So we can say a half mv squared is 120. We know the mass of the cat, 3 kilograms, remember? A half times 3 times v squared is 120. 1.5 times v squared is 120, just doing the half times the 3 to get that to one number. We need to rearrange this now. We need the 1.5 on the other side. We're multiplying, so we need to divide it. So v squared is 120 over 1.5, which equals 80. But we've got a squared in there, we need to get rid of that. So v is the square root of 80, which is 8.9 meters per second. So that is the speed at which the cat is travelling when it hits the ground. The reverse situation we need to have a look at, and that is where we have kinetic energy and it's changing to gravitational potential energy. And so in this situation we have a ball, and we'll say it has a mass, nice easy number, 1 kilogram. We're still on Earth, so gravity is 10 newtons per kilogram, and we're going to throw it in the air, and as it leaves your hand, or as it leaves the ground, we'll have it moving at 10 meters per second. What we want to work out is how high that ball is going to go before it starts to come back down again. Okay, so we'll just bring it back down here. So the first step, we know at the bottom here, so while it's there, onto pen, it's all EK. So let's work out that total, because that total is important, it won't change. EK is a half mv squared, which is a half times 1 times 10 squared, and if you do that in your calculator, it works out at 50 joules. So 50 is what we've got to play with. That's the total amount of energy the ball will have during its journey up and down. So now, away the ball goes, and it stops. Well, it doesn't stop, but at the top of the throw, well, the EK has all been changed into EP. So we know that the value of potential energy here is 50 joules, don't we? Because that's not changing. Formula for EP, mg delta h is 50. Let's put some numbers in. 1 times 10 for gravity, times the h we're trying to work out equals 50. 10 times h is 50. We want the 10 on the other side. We're multiplying here, so we're going to divide 50 over 10. So it works out at 5 meters. So our ball will reach a height of 5 meters.